Everybody. In this video, we are going to go a little old school. We're going to use the teacher's book since Seva seems to be down for us. And I want to make sure you guys get these notes. I will re-record these with the Sevis book as well. So you just have that as a reference. Possibly, I don't know, maybe I won't re-record it. Maybe I will have too much to do to re-record it. But here we go. Let's start with this old school. We're looking at topic 3, lesson 6, example 1. And in this, we have a concept. We have the rational root theorem. This is what's here on top. And what this states is that if p of x equals some polynomial with integer coefficients, if the polynomial equation p of x is equal to 0, or we're looking at factors of the polynomial, because remember the factor theorem is when p of x is equal to 0 or when the remainder is equal to 0, has any rational roots, then each rational root is of the form p divided by q, where p is a factor of a constant term a naught, and q, so when they say p is a factor of the constant term a naught, this is this first term here, or this last term here, and q is a factor of an, this first term here. So you're looking at the final term coefficient divided by the first term coefficient, or the leading term coefficient. So let's look into example 1. From the graph, it appears that 4 is a 0. So I'm looking at this graph. They zoomed really far out. I recreated this graph in Desmos, and I zoomed all the way to negative 1,000. And looking at that, it appears that this graph has at least 2 zeros. So we're going to see, without substituting, how we can determine if 4 is a solution. So in other words, we're not going to plug 4 directly into here and see if that gives a 0. That would be the most ideal. But again, sometimes we're looking at things that are not so apparent, not so in front of us. I can see that's 4 here, but I'm also zoomed really far out. And so that might not help. And again, I could just plug it in and get 0, or substitute it in and get 0. But let's use this rational root theorem, because this does help us as we go along. This does help us prove some theories, prove some identities, prove things. All right, so the first thing I'm going to look at is we are looking at the factors of a naught. So let's think of what the factors of a naught are. So a naught in our case is this negative 4 here. And then our factors for that, let's see, factors for 4 would be positive or negative, because if you're doing a positive times a negative, you'll get the negative 4, positive 1, positive and negative 2, because 2 times 2 is 4, so negative 2 times positive 2 is 4, and then positive or negative 4, because again, positive times a negative gives us a negative, negative times a positive gives us a negative. Okay, so the second part is my an, or my leading coefficient. My leading coefficient in this case is 8. Oh, let me change this to this so we can keep it kind of zoomed in. All right, so our factors for 8, again, we would have the positive and negative, because a negative times a negative will give us that positive 8. So let me think. Positive negative 1, positive negative 2, 2 goes into 8. 3 does not go into 8, but 4 does. 5 does not go into 8. 6 is not a divisor of 8 evenly. 7, and then 8. So there are my factors of 8. All right, so now we're going to take the p and divide it by the q, or the factors of a naught and divide it by the factors of q. All right, so in this case, I'm going to start with 1. Positive negative 1 divided by 1. Actually, let me write this out a little bit. Then we have positive, and that's the thick one. Positive -2. Positive -4. And then we're going to repeat that over and over again. So this is 1. Oh, I like how I didn't change the color there. All right, and then we're going to keep doing that. Positive or -1, positive -2, positive -4, positive -1. And we're going to do that 1, 2, 3, 4 times. Positive -2, positive -4, comma, positive -1. I should put the bar underneath. Positive -2, positive -4. And now I'm just going to divide by these factors. 2, 2, and 2. 4, 4, and 4. 8, 8, and 8. All right, to expand the page. Now what we're looking for here is that if 4 is a possible solution. So looking at this, we do have 4 divided by 1, positive and -4 divided by 1, which is equal to 4, positive and -4, which means that positive 4 is a possible solution, according to the rational root theorem. So yes, I'm going to type this one out. Yes. Actually, let's do this as a sentence. It is possible for 4 to be a solution to our polynomial p of x. And then I'm going to write this one out because my notepad does not like equations so well. A to x to the 5th minus 32x to the 4th plus x squared minus 4. And there you go. There is the rational root theorem being worked out and seeing if 4 could be a possible solution. And there's my Desmos if you want to see what I did. But I will hopefully have the try it here soon. If not, I believe I grabbed them in the assignments. Let's see. Doo-ba-doo. I might not have. Oh no, they're here. So if you want to try the try-its beforehand, you can go ahead and do that. So I hope you guys have a fantastic day, and I'll see you in the next video.